Okay, so hello everyone. Welcome to my YouTube channel, GIS and RS Depot. So now I am going to show how you can easily calculate or how you can easily download NDDI, normalized different doubt monitoring index using Google Earth Engine platform. Okay, so how you can easily calculate NDDI, that means normalized difference doubt index using Google Earth Engine platform, and easily export GeoTIFF images in your Google Drive and make NDDI map, and as well as you can easily make time series chart in time series chart of NDDI index using Google Earth Engine platform. Okay, so already show here this type of map. This is our NDVI map of this area. So first of all, you see a authorized paper for NDDI equation. Okay, so here you see this is the normalized difference doubt index, that means NDDI. Okay, NDDI means normalized difference doubt index computation for mapping doubt severity in this area. Okay, so for example, we see it here. You see in this authorized paper, you see here NDDI formula, introduction, all of the things. If you want, you can easily read it and gain knowledge. So methodology, we see the method. So if you calculate NDDI equation or indices, first of all you need to make NDVI, normalized difference vegetation index, and NDWI, normalized difference water index. Okay, first of all you need this um, NDVI and NDWI, these indices calculation. Okay, so normalized difference vegetation index NDVI. First of all, we calculate. You can use here. You see the NDVI and another one is NDWI. Okay. First of all, you need these two indices for calculate NDDI, normalized difference doubt index. So NDVI formula or NDVI equation is near infrared band minus red band divided by near infrared band plus red band. Okay, so that's then NDWI equation is near infrared band minus short wave infrared band divided by near infrared band minus plus short wave infrared band. This is the equation of NDWI, that means normalized difference water index. And another band combination for NDWI, you can, if you want to see NDWI equation, wait a minute. Okay, NDWI equation is another equation is green band minus near infrared band divided by green band plus near infrared band. This is the NDWI formula. Okay, normalized difference water index. Okay, we see here the NDVI formula and another one is NDWI formula. Then you need to develop this algorithm for normalized difference doubt index NDDI. NDDI means normalized difference doubt index. NDDI formula is NDVI, that means normalized difference variation index minus NDWI, normalized difference water index. Then you use here divided NDVI, that means normalized difference vegetation index, and plus NDWI. This is the equation or formula of NDDI. NDVI minus NDWI divided by NDVI plus NDWI. Okay, here you see the all of the things of the equation NDDI value. This is the severity. Okay, if you see here the very less drought severity class is very less when you this value, and when you see this value minus 2 to 0.7, this is the low value of NDDI. Then another one is moderate NDDI the value is 0.7 to 1.25. Okay, when you find this value 0.7 to 1.25, this is the moderate drought index for your study area. Okay, so this is the process for making NDDI equation or formula, and you see here the chart of the NDDI severity. Okay, so now I am going to um, uh, show in my code editor of Google Earth Engine. We use this Google Earth Engine platform and calculate our NDDI formula. Okay, here you see I use here the Sentinel-2 multispectral satellite dataset imagery. Okay, here you see the Sentinel data set. If you want, you can use here the Landsat. Also, you can use here the Landsat data set. Okay, here you see the this is the harmonized Sentinel-2 MSI multispectral instrument. This is our data set. Here two data set, level 1 and level 2A. Okay, if you want, you can use easily here instead of if you want, you can use here the Landsat data set instead of this Sentinel data set. Okay, then we take a variable name is image. Then we call this our satellite imagery, all of the data set of Sentinel data set. This data set variable name I put here the collection. Okay, then we call this collection and filter our specific bound, filter our specific study area. This is our specific study area. Okay, so here you see, wait a minute. So this is our study area. Okay, already we put here in my code editor. So then we use here the filter date function. Here you see the only 4 month, year of 2024, 1st January to year of 2024, 30 April. Okay, here the 4 month time frame we use here. Then we filter use here the filter mirror function. That means we find here the less cloud pixel percentage images. That means the better satellite images, which is not less than or not more than 5% or 10% cloud pixel percentage. We filter here the filter mirror data function. Then we make a median composite image, and then we clip our study area. All of the things we already filtered and stored in the variable name image. And in this data set, easily you see the band available band information of the data set. Wait a minute. Okay, I open in our another tab. Here you see this is the band combination. Band 1, it is the aerosol band. Band 2 indicate the blue band. Band 2 indicate the blue band. Band 3 indicate the green band. Band 4 indicate the red band. All of the band combination of this supplied satellite data set, harmonized Sentinel multispectral instrument. So here you see already we see from this authorized paper, you see here the NDVI. NDVI, when you calculate the NDVI formula, okay, wait a minute. Okay, so when you see the NDVI formula, you see here, okay, you see here the NDVI formula, all of the things, the near infrared band minus red band divided by near infrared band plus red band. So here you see near infrared band is stored in the variable name band 8, and red band indicates the band 4, B4. Okay, so here you see the we first of all we call our red images, call our first of all we take a variable name is red, and we call this filtered images and select our B4 band. Then same way near infrared band, and another one band we put here for calculation NDWI. Okay, so NDWI, when we make NDWI, we use here the near infrared band and short wave infrared band, and for NDVI you use here the red infrared band and near infrared band. Okay, so that's why we put here the 3 band. So now we develop NDVI formula. Okay, NDVI formula. We make a comment NDVI. Okay, NDVI formula. NDVI formula equation already we see near infrared band minus red band divided by near infrared band plus red band. Already this band for red band and near infrared band B8 is stored in the variable name NIR and red. We already first tag here the NDVI formula and rename the NDVI and make a layer map.add layer. We use here we call this layer of NDVI equation equation or this NDVI algorithm. Then we set the minimum maximum value and use the visible color plated. Then we use the layer name is NDVI. We set the layer name is NDVI. Then we already we develop our NDVI for equation or formula. Okay, so the next step we make indices of NDWI. Okay, NDWI equation. So NDWI equation already you see here. The NDWI equation already in this authorized paper. Near infrared band minus short wave infrared band divided by near infrared band plus short wave infrared band. If you want, you can use also this equation. Equation is green band minus near infrared band. Also the green band minus near infrared band divided by green band plus near infrared. Also you can use this equation for NDVI. So now I use here this equation, authorized equation from this authorized paper. So near infrared band minus short wave infrared band divided by near infrared band plus short wave infrared band. Okay, so now we use here the near infrared band subtract by short wave infrared band divided by near infrared band addition short wave infrared band and rename this band name is NDWI. That means we already develop our NDWI formula. Okay, and we see here the map layer function. Okay, we see already you see here this here the layer function, and then we calculate. You see here the NDDI formula. We put here the NDVI equation minus NDWI divided by NDVI plus NDWI. This is our NDDI equation. That means normalized difference doubt index. Okay, so already we develop here. Already I develop here this NDDI equation and all of the things all of the thing we put here. And if you want to say in our map interactive view, so you see here that this is our NDVI layer. Okay, this is our NDVI layer. Here you see we see here the band combination. The red band, red color. This is the color plate value. Red color indicate the low NDVI. That means low color indicate the near -1 value. Low color indicate the red color indicate the near 1 minus value, and yellow color indicate the middle value, and green color indicate the plus near plus value or near 1 value. Okay, so you already you know the when you make a NDVI equation, positive value show the more NDVI. Okay, and negative value show as a water body, or and middle value show as a another, suppose build up area or bandland area or anything. Okay, so you see here the NDVI, you see here that this is a red color indicate the water body. Okay, if you remove from this layer, so you see here the water body of this of our of my study area. You see here the water body indicate the show as in map view. Water body show as a this type of blue color. Okay, so we open when we NDVI layer. So this is the red color indicate the water body, and more green color indicate the more vegetation area. Okay, and yellow color indicate the moderate vegetation area or anything, suppose build up area or bandland area or anything. Okay, so already you see the NDVI layer. Now I am showing NDWI. Okay, when you go to the setting of the NDWI. Here you see the negative value. Suppose we use the stress 98% or 100% for better looking or better visualization. So now we 100% stress for looking good. Okay, so now we apply. So now you see, okay, so you see here the NDWI, that means water body show as a plus value. That means water body did not show as a negative value in NDWI. NDWI, here NDWI map, vegetation area show as a negative value and water pixel show as a positive value. Okay, so here you see that this is a lots of the water body show as a ND. This is our NDWI TIFI map interactive view of the satellite imagery. Okay, already you see here the two layer NDVI and NDWI. Now I am going to show the NDDI layer of this study area. Here you see, okay, when you go to the our this, okay, I with the custom 100% for better looking. Here you see the white color. White color indicate the negative value. Suppose we see here the yellow color indicate the negative value, and this type of color, this blue color indicate the middle value, and red color indicate the, suppose red color indicate the positive value. Okay, so now click to the stress 100% and click to the apply. So now you see here this type of map wait a minute. Okay, wait a minute. So we since this type of, okay, wait a minute. Okay, middle value show as the, okay, if you want to change this type of color. Okay, now we do the, okay, sorry. Okay, now NDWI layer we see the color palette. So yellow color, okay, already we set already because it did not working, because already we put here the visualization color of NDDI, white color, blue color and green color. Suppose you see here the you see this color, red color indicate the positive value or near positive value, and suppose you see there the pink color indicate the negative value, and moderate color indicate the blue color. Okay, or, and now we click to the run. So when you click to the run, you see easily this is the NDVI layer, NDWI layer, and this is our NDDI layer. Okay, so that is normalized different doubt area index. Okay, now if you want to check for this area, this is our almost this is you see in our map interactive view. This is our, okay, wait a minute, this is our this part we see here. Okay, when we check all of the layer, you see this type of map. So now I am going to inspector tab and inspect all of the result in on this map. When we click to the this here you see the this type of this area show as a more red color, that means more NDDI value. Okay, here you see when you click to the inspector tab, here you see the NDVI NDVI value show as a 0.2 and NDWI value show as a negative value, because in this area no water body. That's why this NDWI value show as a negative value, and in this area NDPI, here you see the vegetation area. That's why the NDVI layer show as a positive value, and NDWI value show as a 1.9, almost near 2. If you want to check NDDI value range for you know, okay, NDDI value, NDDI, okay, wait a minute, NDDI, not NDVI. Okay, okay, here NDDI value already we see here this authorized paper. So you see here the 0.7 to 1.25 is a moderate NDDI value, and 1.25 to 3.00 indicate the high NDDI value, and more than 3 value show as a very high doubt severity area. So that's why this area, this our inspected area is very high drought severity area. In this time you see here the 1.9. Okay, if you check in this area, if you check in this area, wait a minute, wait a minute, if I want to check, if I want to check in this area, in this part, in our inspector tab, here you see the NDVI value is 0.36 and the WI value and NDDI value is 0.84. That means this equation show as a moderate. Okay, moderate value of the drought severity. Okay, so this is the all of the things of the equation of the NDDI. If you want to export, if you want to export this NDVI geotiff images and make a map layout in your ArcGIS or QGIS or NVI application, just if you see here the export function, export function, and export in your Google Drive as a NDVI layer, then we use here the NDWI geotiff images, and also we develop the NDDI images. Okay, so in next video, I will try to discuss how you can easily make NDDI, NDVI and NDWI time series chart over period of time. Okay, time series chart, make a time series chart over period of time, and this data NDDI, NDWI, NDVI data in export in your export in your drive as a CSV file format and your Excel sheet, and you this data add in your research paper or presentation paper or anything. Okay, in next video I will try to show how you can easily make time series chart. Okay, time series chart over a period of time. This type of time series chart. Okay, this type of time series chart I will try in my next video. This type of NDVI value, NDWI, NDDI, all of the things I will discuss in my next video. Okay, so thanks for watching. So also I have a course, I have a course of Google Earth Engine for basic to advanced. Wait a minute. Okay, so now I am discussing about my Google Earth Engine course, and all of the course of my Google Earth Engine, all of my course. Here you see the Google Earth Engine. This is my website. So here you see the registration is open for 8 days. 8 days online training program on Google Earth Engine for beginners to advanced level for remote sensing analysis, GIS and remote sensing analysis. Our upcoming batch start from 31st May 2024, 31st May, and admission last date is 13th May. So last date of booking is 13th May. All of the course content, if you want to join in my Google Earth Engine course for basic to advanced level for GIS and remote sensing analysis, 8 days online training program. So it's simply you knock this WhatsApp number or this email. Okay, so easily find out this WhatsApp number from this website, and also this email also this email address. So here you see the all of the course content of the 8 days. This is the basic to advanced course on Google Earth Engine for the beginners to advanced level. We focus this type of people, or person who don't have any knowledge about any programming language, suppose JavaScript language or Python language or anything. Okay, so we in this course we focus this type of people who don't have any skill of the programming language to run Google Earth Engine and all of the function about Google Earth Engine for remote sensing analysis. In this time, you see the end of the course, you will be able to manage easily manage remote sensing work using Google Earth Engine platform. Suppose LULC, land use and cover classification map, NDVI, NDWI, DEM dataset, digital elevation model dataset, land surface temperature monitoring, air quality monitoring, all of the thing and more to topic you see, you learn from this my course. Okay, here you see the 8 days of the course content. Introduction about Google Earth Engine and how you can easily create Google Earth Engine account. Then we all of the introduction of the basic anatomy on basic part of the Google Earth code editor. All of the thing we step by step basic anatomy of the Google Earth code editor and basic JavaScript syntax. Okay, the basic function, basic structure, basic knowledge of the JavaScript syntax for run Google Earth Engine. So then we learn server object versus client object in Google Earth Engine platform, and how you can easily import and export any raster data type or any vector data type in using Google Earth Engine platform. And you learn of the things, the band combination using satellite imagery, all of the satellite images, suppose Landsat, Sentinel or Modis dataset, all of the things you easily learn and gain the knowledge of band combination of satellite imagery and band combination of different dataset using Google Earth Engine platform. Then how you can easily filter, of any dataset or of satellite imagery in Google Earth Engine platform and display dataset, and how you can easily make normalized different vegetation index, enhanced vegetation index, normalized different water index, normalized different build-up index, and all of the indices you learn from this course. And then we soil moisture index, then we calculate average proof soil moisture index using Google Earth Engine platform. Then how you can easily land surface temperature monitoring using Google Earth Engine platform, as well as use Modis dataset and Landsat dataset. And you see in this course you learn calculate land aerosol optical depth, AOD, that means land aerosol optical depth using Google Earth Engine platform, and how you can easily make time series chart, all of the things that suppose LST, AOD and all of the things time series chart. And then you can learn air quality, how you can easily calculate carbon monoxide, that means all air quality parameters. You can easily carbon monoxide, a mole per meter square unit, and then using Google Earth Engine platform. Then you calculate nitrogen dioxide indices, then you can sulfur dioxide and methane, or as well as ozone, carbon monoxide, carbon dioxide, all of the air quality monitoring you learned from my course. And all of the you to make time series chart over a period of time, all of the air quality monitoring. Then you learn how to make hillshade, slope map, aspect map using different dataset, suppose NASA SRTM dataset or any TM dataset using Google Earth Engine platform. Okay, how you can easily export this map or animation map or video from using Google Earth Engine platform. And you learn here from this course how to create land use land cover classification map using Google Earth Engine platform, and also you learn supervised and unsupervised classification technique in Google Earth Engine platform, and random forest and card classifier in Google Earth Engine platform. How can you can easily make accuracy assessment of land use land cover classification map, suppose producer accuracy, kappa accuracy, consumer accuracy and others accuracy. And then how to calculate area, for each LULC class using Google Earth Engine platform. Okay, so all of the course content you learn from this Google Earth Engine code 8 days course content. Already you said the registration open. Okay, if you want to join in my Google Earth Engine course, you easily knock in my WhatsApp number or this email. Okay, all of the information. 31st May we run our running batch. Okay, admission last day is 13th May. Okay, so you simply knock in my WhatsApp or email number and confirm your seat. Okay, all of the things of my Google Earth Engine course. So if you want to join, just simply here you see the another course of the Google Earth Engine using Google Earth Engine platform. Here is the land use and cover classification course. This is the also only focus on the specific advanced level of LULC land use and cover classification, course content, how to create land LUC map, include in platform, supervised, unsupervised, and random forest and card classifier, accuracy assessment of the LULC, suppose producer accuracy, cup accuracy, all of the thing, and how you can easily chart on time series chart and LULC chart of area calculation and export data, and as well as you can learn from this course how you can easily make this type of LULC map and all of the things. Okay, so if you join in my course, just simply knock in my um, WhatsApp number or email address. Okay, so thank you, thanks for watching this video.